Welcome back to my channel. So today I'll be going through Bukit Panjang Primary School. This is the 2024. This is the prelim question number 37 on energy, as well as there's a little mix of forces. Okay, so Ryan has a toy glider plane as shown over here. He placed one end of the rubber band on the hook. Okay, on the hook over here, and at the bottom of the plane, and stretch the rubber band using a wooden stick. So the rubber band over here is stretched. Okay, when it's stretched, it will possess elastic potential energy. Okay, they are stretched to a distance of dcm. So when the toy glider plane release, it move a distance. So it should probably move from here, and it drop down some distance from the ground. So it move a distance before dropping to the ground. So fill in the blank to show the mean energy conversion when the toy glider is launched. Okay, when the toy glider is first launched, right? The potential energy in the rubber band will first converted to kinetic energy first, because the toy glider plane has to move a distance. So as it moves a distance, it will climb higher and higher and higher above ground until reach a maximum height, then it start to drop down due to the pull of gravity. So this one is potential. Okay, so in this case it will be kinetic and potential. So these are the two more straightforward. So the order is actually quite important, because over here this is a conversion arrow, so you cannot put the other way around. Okay, so it must be kinetic first, followed by potential. Okay, once it moves first, then it can go to a higher height. Okay, so Ryan used a thinner rubber band of the same length. He then stretched the rubber band to dcm, okay, to a certain distance, same as above, before releasing. So would the plane move a greater, shorter, or same distance? So if you have a thinner rubber band, right, you have to ask yourself, when you stretch to the same distance, would it have the same amount of potential energy or not? Okay, one way to look at it is this. So this one is the thinner rubber band, this one is the thicker one. Okay, some of you may have seen this kind of rubber band before. This one is usually the most common. Okay, this one is usually used by the postman, where they have to bundle their mail together, so they have to use a thicker rubber band to be able to do so. Okay, so if you were to stretch both the red and the yellow rubber band to the same distance, right, you have realized that the thinner rubber band is easier to stretch to the same distance, because this one is more elastic, it's more stretchable. The thicker one is more stiff in this case, so it's harder to stretch. But if you manage to stretch them to the same distance, right, this one will have more potential energy. Okay, this one will have less potential energy. So now we know that if we use a thinner rubber band, we stretch them to the same distance, it have less potential energy. Chances are it's going to convert to less kinetic energy and travel a shorter distance. So the choice is very clear. Okay, choice shorter distance. The evidence is thinner rubber band. Thinner rubber band is more elastic, more stretchable, require less force to stretch to the same distance dcm. Then the reasoning will come back to your energy conversion. So thus, less elastic potential energy is stored or possessed in the rubber band, which can be converted into less kinetic energy, causing the in this case, causing the toy glider to travel a shorter distance. So this part is pretty straightforward, and the reasoning relies on your energy conversion. You will need this part to be able to explain it out fully. Okay, so the toy glider is made out of material that is smooth. Okay, explain in terms of energy conversion, how this helps the toy glider to travel through the air faster. Okay, so, this one is a little bit related to force. So when the toy glider is made out of very smooth material, right, chances are it can cut through air more easily. Cut through air more easily. This means that there is actually less air resistance. Okay, the idea of air resistance is actually a concept related to force. So in this case, when the airplane has less air resistance between, which means in this case is actually a friction. Okay, friction between the air and the body of the plane. So when the plane is moving this direction, right, air resistance is acting in this direction. But smoother material because it's smoother, it has less of this air resistance opposing the motion of airplane. So in this case, when you have less air resistance, you can take it as less friction, so less heat is being generated, okay, in this case. So if you have less heat, right, chances are the kinetic energy of the airplane will convert into less heat energy and allow more kinetic energy in the airplane to travel even further or travel even faster. Okay, so in this case, you have to answer in terms of energy, not forces. Just remember this. So it will be something like this: less kinetic energy in the toy glider is converted to heat energy. Okay, this part you don't really need to add in, but if you want, you can add in as well due to air resistance. Okay, to answer this in force is also possible. You can say the airplane is smoother. The material is smoother. It will have less air resistance, allow the airplane to cut through the air at a faster speed. Right? But this question asks you to explain in terms of energy, so this will be the best answer. So sometimes you will see this kind of terms that is being used in your question. So it's actually what we call a domain specific. Okay? Or rather you have to answer in a specific domain. Okay? That means if they ask you to answer in terms of energy, you have to answer in terms of energy and not use forces. Okay, so this part will be more or less how you answer this question. So let me put it here. Thank you very much.